Hello, this lesson is about specific heats. So let's learn what are specific heats and apply it. Alright, so by definition, specific heat is the amount of heat needed to raise a unit of mass from a substance to a unit of temperature. For example, it can be the amount of heat needed to raise 1 kilogram of water in 1 degree Celsius. But these are the most common units we use when doing calculations. So we can define the specific heat by the terms of the partial derivatives from the functions of internal energy and enthalpy. But what we really need to know is that the specific heat changes with temperature, and if we measure it in a system with constant volume, it will have a different value from a system with a constant pressure, for example. So depending on the system you have, if it is a constant volume or a constant pressure, we can use different specific heats. So we know that for gases, Cp and Cv are pretty different, but for solids and liquids, they're actually very similar. But why we need to know about the specific heats? Well, they're very useful when calculating the heat transferred. So we know that the heat transferred is equals to the mass of an object times its specific heat times the difference in temperature between initial state and final state. Well, taking a look into this formula here, we can notice that if we double the mass, we're also doubling the amount of heat transfer. And if we double the difference in temperature, we're also doubling the amount of heat transfer. Just keep in mind, we're doubling the difference in temperature, not the temperature itself. So it's the difference between the initial state and the final state. Well, sometimes remember that the specific heat depends on the temperature, and sometimes the difference in temperature between the initial and final states are very big, so we have different specific heats for each temperature. So one thing that we can do in this case, in cases like this, we can take an average specific heat for the object, taking into account the final and initial temperatures. Okay, so let's practice. We have a waterfall that is 800 meters high, and the initial temperature of the water at the top of this waterfall is 15 degrees Celsius. So what would be the temperature of the water when it reaches the bottom? So let's assume all the energy of the falling water changes into heat energy. So we know that the Cp of the water in this case here is 4.17 kilojoules per kilogram degrees Celsius. So if all the energy of the falling water transforms into heat energy, we can make the kinetic energy equals to the heat transferred. So you know that the kinetic energy is mgh, and that the heat transfer is mCp delta T. Isolating the difference in temperatures, we have that it's equal the acceleration of gravity times the height divided by the specific heat. And we can now insert the values here. We have the final temperature, it's the thing we want to find. The initial temperature, 15 degrees Celsius, acceleration of gravity, the height, and the specific heat of the water in this case. and then we have a final temperature of 16.95 degrees Celsius. Okay, so try to apply your knowledge now. Suppose you're pouring 250 grams of engine oil at 300 Kelvin into a half kilogram aluminum pan with a temperature of 150 degrees Celsius. Assume also that the pan is placed on an insulated pad and that a negligible amount of oil boils off. So what is the temperature when the water and pan reach thermal equilibrium? So I'm giving you the specific heats of the engine oil and the aluminum pan. Think about it, do your calculations, and write your answers in the comment sections. Thank you.
Want to learn more? Check out the next video. Quick reminder to subscribe to GeeklyEDU.